So for section 2.4, we got quite a bit of different types of graphs that they're going to look at, but I'm going to focus on the primary ones that I'm going to be testing you on. So first thing you need to be able to do is you do need to be able to make a stem and leaf plot. Okay, so when you do a stem and leaf plot, one important thing is that you include a key. Generally what happens is we will have the stems and the leaves, and they're one digit apart, meaning if the stems were hundreds, the leaves would be one digit less, it would be tens. So they're always one kind of digit apart. So if the stems, and you have to specify what they are, if this was hundreds, then this would be one digit less, tens. If this was tens, this would be one digit less, ones. If the stems were thousands, this one would be hundreds. If the stems were ones, then these would be tenths. We're not going to get into as many of the complicated ones, but just the key is that they're one digit or one place value apart. Okay, so the leaves are always one place value less than the stems. When I look at the information here, we have numbers ranging from, let's see if we have a minimum. I think I see 18 might be the smallest. No, 4. So that looks like it'll be our minimum. And our maximum, if I'm scanning through here, I see 67 might be our max. Okay, so I'm looking at most of these are going by like 10, so like 10s, 20s, 30s, 40s. So when I go down here, I'm probably going to make my stems 10s, and my leaves would be one digit less, so 1s. And what we do is we separate this, and they kind of cheat down here below, so just kind of follow along with me now because you need to make these by hand anyway, is we are going to put our stems on the left and our leaves on the right, and our stems, if we're going from tens, the lowest number we have is 4, which would have 0 tens. And then we'll have the 10s, the 20s, the 30s, the 40s, the 50s, and it looks like our highest number is in the 60s. Okay? So what I would do now is I would go through each of these numbers and I would fill in the leaves. So the number 4 would represent 0 tens and 4 ones. So you'd stick a 4 there. Number's gone. Now I'm looking for any tens. I see an 18. Oh, let's see. I see an 18. I see a 19. So what we would do here is we wouldn't put the 18 and then the 19. What you do is you put just the leaves. You just put the ones. So you would put an 8 and a 9. Okay? So you only put the ones digits over here. Some key features. There needs to be no commas. Okay, so if you put a comma in here, I will mark you wrong. Don't do that. And then basically we only put a single digit for our leaves. L-E-A-F-S. So you don't put an 18 and 19. This represents 1 8 is 18, 1 9 is 19. I don't really feel like searching through all these numbers. So what I did is I actually took a minute and I typed these in my calculator. So if you want to pause, you can do that real quick. If you want to keep searching through these, you can, but chances are you're going to kind of maybe miss some of the numbers. So like I said, I took some time right here and I typed in all of the, how many numbers were there? Looks like 41 numbers, okay? And the reason I did that is because I can sort this. And this is a good skill to have anyway, so I like to review it. Basically, I can't sort it when I'm down here, so a lot of people will go here and go, what is it, data, and they're like, where does it go? Or is actions? Actions, and they're like, I can't click sort, right? Well, that's because you're trying to sort a single number. You have to either go above it or, somewhere outside of that. And now when I go actions, it's like, hey, would you like to sort that entire column? Okay? And I didn't quite pull up, so let me try that again. 1 and 1 and 6. Let's do it. Oh my goodness gracious, what is going on? There we go. Still not. Let me just try highlighting the whole thing. Hopefully you're not having this many problems with yours. Menu, 1, 6. There we go. So sort column A in ascending order. What this does is it helps me see that there's only a 4, an 8, and a 9, and my next lowest number is 23. So in the 20s, I see a 23, 24, and 26. So what I'll do is I'll put a 23, 24, and 26. No commas, and only the ones go in there. Okay. In the 30s, we've got 31, 32, 34, 35, 35. 31, 32, my brain. 34, 35, 35. Okay. Make sure there's only two 35s. Yep. 37, 39. So I put a 7 and a 9. What does this 7 represent, right? 3 10s and 7 1s. 37 and 39. You put all the 10s together, and then all the 1s go in on the leaves. Now we're going to do the 40s. I've got 40, 41, 42, 43, 44. So 1, 0, 1, 2, 3, 4. How would I put 40? Well, that's 4 10s and 0 1s. 1, 2, 3, 4. Let's see if there's more of those. Yes. 2 45s, a 48 and a 49. 2 45s, a 48 and a 49. And now we're in the 50s. 3 50s, 2 51s, 3 50s, 2 51s, 2 51s, okay, and 52, 53, 54, 54, 55, 52, 53, 53, 54, 55. Nope, there were two 54s, so let me fix that. 53, 54, 54, 55. Okay. Oop, another 55, 56, 57, 57. Out there. So 5, 6, 7, 7. And then finally we're in the 60s. 60, 62, 63, 65, 67. 2, 3, 5, 7. Let's see if that was right. 2, 3, 5, 7. And that would be it. So that would be a stem and leaf plot. And that is something that's on the quiz, and that's something that would be on the test. We can also, and they kind of give you this nice little clean diagram, but this is kind of what I would expect to see turned in with the key. Okay. Other types of stem and leaf plots that we can do a split stem and leaf plot. And basically this would be if we don't have enough categories, okay? So when I do a stem and leaf plot, I'm going to want at least 5 categories, okay? Or 5 stems. So this has 0, 1, 2, 3, 4, 5, 6, 7. So this has 7 categories. It would be fine. But if I wanted to, if any of these were really tall, or any of these, or if I didn't have enough categories, then basically we could split the stems. So instead of putting a 0, we'd put 2 zeros, 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, and 2 6s. So if I did a split stem and leaf plot, what we're doing is you're dividing all these numbers, which would have been from 0 to 9, and you're splitting them. So the first 5 numbers go on the top, the second 5 go on the bottom. So what goes up here is not 1 through 5, because remember, we're splitting it. It would be from 0 through 4 would go in the first, and then 5 through 9 would go in the next one, and then this would represent 10 through 14, 15 through 19, so on and so forth. Okay, so we've split the stem so that 0, 4 would go on the top, and then there would be nothing there, so we would leave that blank. And then 18 and 19, the 8 and 9 would go on the second, so we'd have an 8 and a 9. Now this is one where it's going to actually make a difference, because the 3 and the 4 would go in the first group of 2s from 20 to 24. So that would be the 0 and the 4 would go there, and the 6 would go in the other group. Okay, so you're splitting up the data, you're spreading it out. It's not going to make much of a difference for us on this one. That wasn't really a necessity to do it, but it is something we do sometimes. So let's keep practicing just to see this. So in the first one would be 30 through 34. Remember, that's 5 numbers. So 31, 32, 34. Those would be the numbers that would go in the first 3, 1, 2, and 4. And then the rest of them would be our 5 through 9. For the 40s, the first would be 40 through 44. So that would be 40, 41, 42, 43, 44, and the rest, 5, 5, 8, 9, would then be split, spread out a little bit. 50 through 54 means all of these suckers would go in that first one. So that's what? 3 zeros, 2 1s, a 2, a 3, 2 4s, and then the rest, 5 5, 6 7 7, would go on the second one. 60, 62, 63, 65 would go in the second one, and 67 would go. So that's just a couple options, different ways of looking at it. But you will have to do a split stem and leaf plot to get all the categories on the quiz and potentially on the test, so just be careful with that. Other things, sometimes they'll do back-to-back, where if I'm comparing two, they'll put one stem and leaf plot to the right, and then they'll kind of do another one to the left of it. You might see those. I'm not going to make you do one of those, but that would be something we can do back-to-back sometimes. But those are the ones, these are kind of the ones you need to make sure you know for the quiz and the test. Advantages and disadvantages. So let's start with advantages to this. How does this compare, right, to we've done histograms? I definitely some advantages to the original list of data. I can't really read much with a big list of data. Like a histogram, I can still see the shape of the distribution, right? So I can still see the shape. In fact, if I took either of these histograms and I just rotated them 90 degrees, they would look just like the histogram for these. Okay, my classes would be, these would be on the x-axis, and the y would be the frequency. This is what the histogram would look like. So this is why on the quiz and the test, I have you start with the stem and leaf plot, which then you'll fill into a frequency table, and then you'll build the histogram from that. I can still see that shape here. Okay, some benefits over a histogram though. When I have a histogram and I have bars, I can't tell the lowest number. Like here, I can actually go, what is the lowest number on here? Well, that's the 4. What's the highest number? 67. So I can see here kind of I can still see the lowest number and the highest number. Okay. We can still see, I can see where the approximate center is, but I can still see the numbers. Disadvantages to this scares people, right? People don't like numbers. They want a picture. So if you showed this to people, if you showed this to kind of the layperson that doesn't really know statistics, this is really intimidating. It has values. Visually, I can still see things. I still have the numbers in there, but we don't use this display very often if I'm doing like a demonstration because these numbers scare people. The next thing we're going to do is a pareto and a pie chart. The pareto I don't really use these much, but basically it's a bar graph. But specifically, it's a bar graph that is arranged in order from the lowest to the highest frequency. Okay. It says we only use this with qualitative data because we've done histograms. That was with quantitative data. So if I have numbers, I put it on the histogram and I have all the bars pushed together. This bar graph, we are going to have spacing between the bars. I hope I have that on there. So make sure we have spacing must be between the bars. Because it's not quantitative data, we're dealing with qualitative data. We separate the data. Qualitative data, I also call that categorical. So if we have categorical, so if we have categorical data, then that would basically be, we'd make a Pareto chart or a bar graph with that. Okay, here's an example, and I put some numbers on here. This is actually harder than, like you will have one of these on the test, but this is harder than what you're going to see. I already have the numbers in order. They won't always be given to you in order, but the idea is that we are going to take all of these blue, green, purple, red, black, orange, yellow, brown, gray, and white, and agree hopefully that those are categorical. Blue is not more than green, is more than purple. The colors themselves are just categories, right? So those are going to be what goes on our x-axis. So I'll leave some space, and right here I would put blue. And then next to it I would leave a space, and then I would put green. And then a space, and then purple. Then a space, and then red. I don't know why that's acting up. And then a space, and black, and I'm going to run out of space. So let's add some lines, and then a space, and orange. Space, and orange. And then a space, and yellow. And then a space, brown. And then a space, gray. And then a space, and white. Okay? So those categories go down on the x-axis, but they were not put together. They are separated. The y-axis is still going to be whatever the frequency, or in this situation, it will be a relative frequency. Frequency, also known as a percentage. Okay, so our first one, we got to figure out what the scale is going to be. I have numbers as high as 29 and as low as 2. If I went by like 2%, 2, 4, 6, 8, 10, that's not going to make it all the way to 29. Some people go, we'll go by 10s. Okay, 10, 20, 30, 40. We've already gone way higher than we need to. Okay, so then we're like, okay, well, let's split it, right? That's kind of the idea that we did, that we don't want to get there too quickly. So what if we did like 5s? 5, 10, 15, 20, 25, 30. That'll work. That'll get us to 29. I could, if I really wanted to be kind of picky, I could go by 4, 8, 12, 16, 20, 24, 28, 32. That would work. We don't normally split things like that. I'm okay with 5. So I'll do 5, 10, 15, 20, 25, 30, 35, 40. That's what way higher than we need. So blue goes up to 29%. So I'm going to draw a bar that is just below the 30. Ooh, these aren't in order, are they? Uh-oh. Hopefully you're screening at your script. So that's the next one should be black. So I need to move that. Dang. Dang, dang, dang. Hopefully you have a good eraser. So black is 24%. So I'm going to put that just below the 25. The idea with the Pareto chart is, yes, it's a bar graph, but they do have to be in order. Okay. So 29, 24. I think now I'm on purple, so that'll be fine. That one's 11, just above the 10. Now I'm on the 10, which is green, so we're going to have some issues here. So I probably just need to make some of these go away. That dang. All right. So next we're going to have, what is it, green, which was 10. So that should be right on the 10. I'm not pulling out a ruler, but I mean ballpark where that should be, to be very careful with that. After green, looks like we have red, and that should be 8. So above the 5, below the 10. After that, we have orange, yellow, both match. So you could actually do those in any order. It doesn't matter because they match. Both of those are, what, 5%? I'll bring that line over, about 5. If you had yellow, orange, I would not mark you off for that. Same with brown, or no, not yet. Brown would be 4. So brown would be slightly below that, 4%. And then gray and white, technically the order here wouldn't matter because they're both 2%, so they'd both just be kind of this little bar. And that's what a Pareto chart would look like. Just kind of ballpark it. Some of them can be the same, that's fine, but it is in decreasing order. Expect that on the test. I also will have you do a pie chart. I don't care about calculating the central angles. Honestly, we kind of ballpark it. And so what we do is we find the percentage. I take this and I go, look, wouldn't this be 50%? Well, none of our numbers were 50%, but I could go up here and say, well, I had a 29%. That should be, well, if I cut it this way, that's 25. Wouldn't 29 just be a little more than that? And so that would be my 29% or blue. Okay. The next one I see is, what was it? Black, which was 24%. So I could do that same idea of cutting it to 25% and then just bring it up a little bit and call that one black. Purple was 10. I'm sorry, purple was 11. Green was 10. So what I'd start doing is kind of ballparking and go, okay, if I take these three, that would make 40, 50%. So green and purple are about the same. If I added kind of these three numbers, they would add up to 50%. So I'm going to take the green and the purple. Purple's a little bigger. And take this right here and cut it so that one of the pieces is just a little bigger than the other one. And the one that's a little bigger is going to be, make sure I do this right, purple. And the one that's a little smaller would be green. Okay? And it's just a little bit. If you don't like that, you can make the line a little more pronounced, but just a little smaller than the other one. Okay? What are we left with now? We've done purple, green, red, orange, yellow. These are where it's going to start getting weird. Red is 8%, so it should be a little less than 10. Orange, yellow are 5, brown, gray, white. So this is where it's going to get a little weird. The one that I have on the quiz and the test, it won't be as hard as this. But so we have about 26% left. Half of that would be 13. I'll cut that a little shorter. We're going to call that about 10, or what was the next one? 8% would be red. The next one's 5%, a little less than that. I don't know why it's doing that, but a little less than that. Let's see if I can clean that up. So that was red. Take something that's a little wider, call that about 10%, and then split it in half. So that would be 5 and 5, and that was orange and yellow. And then what's left? We have brown, gray, and white. Brown is 4%. And then the gray and white should be the other kind of split in half. Gray and white. If I have something like this on the test quiz. It's not going to be this many categories, but I'm just kind of showing you how I ballpark it. If you want to get exact, what you would do is you would take the 360 degrees and multiply it by that percentage, and that will tell you exactly how many degrees to do. But honestly, if I'm doing this, I'm going to be using technology to do this for me. And if I'm asking you to make it, they should be numbers that are going to be way easier to ballpark. I'm looking for blue to be bigger than black, black to be less than a quarter, blue to be more than a quarter. If one is slightly bigger, it should be slightly bigger. This is a bit of ballparking on that. And then the last thing we need to talk about is called the scatter plot. Okay, so what we're going to do is we're going to take the age and the weight. So we're going to say there should be some correlation in the quantitative data between the age and the weight of a bear. That makes sense. The older the bear, right? If you're talking about ages and months, a younger bear should weigh less, and as they get older, they weigh more to a point. So be careful. So we're going to say that age is our X, weight is our Y. Okay. When I graph this, I will be using technology to do this eventually, but for now I want to show you what you're going to need to be able to do on the quiz and on the test. Actually, on the quiz I have you could use technology, but on the test for sure, be able to plot these by hand. Once again, this is harder than what you'll be seeing on the test. On our x-axis, we're going to put the age. So label it age in months. On the y-axis, we're going to put weight in pounds. Some key features here. This is different than a histogram. We are okay to shrink both the x-axis, which we've done on a histogram. We've shrunk the x-axis before, but we can also shrink the y-axis on this because I'm not trying to look at scale. I'm just trying to see a pattern here. So we are allowed to shrink both the x-axis and y-axis on a scatter plot. Make sure you keep equal scale as we go. So if I go on the X and I'm dealing with age, my lowest age is 8, the highest one is in the hundreds. I don't want to go 0 to 10, 10 to 50, right? I want to keep equal spaces. I want to be able to get to 100. So we might go 10, 20, 30, 40, 50, 60, 70, 80, 90, of course. 100 and 110 should be enough. For the y-axis, I don't have to start at 0. Since the numbers are smaller, we might be able to do that. The lowest weight we have looks like 34, and the highest is in the hundreds. Okay, so I could sit there and shrink it and start at 34, but since we have numbers that are kind of close to 0, I can start at 0. Remember, I want to get all the way into the hundreds, so I might just go, what was it, 100 to 400? So 100, 200, 300, 400. Now I want a little more precision, but that's going to get me at least close to that 416. So then what I do is maybe I'll cut each of those in half so that I have my 50s. And same all the way up here, maybe I keep all the way up to 450. Now what you do is you plot these as points, x comma y. This is 19 comma 80. So I go to 19 right in front of the 20, and I go up to 80 below the 100. It's an approximation, but I can see before the 20, before the 100, that is 19 comma 80. 55, 344 would be between 50 and 60, 55, all the way up to 344 should be below the 350. So below the 350 might be a little high. 81, 416, so right past the 80. 416, this I think is our highest point, so just above the 400. Okay. What are we at? 115 and 348. So that's going to be kind of frustrating. Let me see if I can get this in a different color so we can see it. So 115 and 348. 48. So like here. Sorry about that. Where are we at? 104, 255. 104, 250-ish. 100, 220. 100, 250. A little less would be 220. 56, 262. Should be above the 250. Okay. 51 and 360. Kind of right here. 57, a little closer to the 60. 204 should be really close to the 200. 53, 144 should be below the 150. 68, 332, so way up to the 300s, about 332. Maybe a little high. I'll make that one a little lower. Where were we now? 8, 34. Oh, it's a tiny little bear. And 44, 140. So 44, 140 below the 150. 32 up to 180. Ballparking it below the 200. And 20 to 105. Is this perfect? And people go, yeah, you made it. You're the teacher. It must be perfect. No, just you're ballparking it, but I can see if there's a point that's way off. I'll be able to look at your paper and go, oh, yeah, you missed a point. Didn't plot that right. But you should be able to sketch these points by hand. There will be something like this on the test. Way easier, but there'll be something like this on the test. What are you going to do on the homework? I hope you're not doing all of those by hand. We have technology, right? So what I've done is I've already input those lists in. First is my X, second is my Y. If you need to pause the video and do that real quick, but you need to make sure you input those points. Okay, so I paused long enough. I'm going to keep going. If you need to pause the video, you can. But be careful because we've graphed before. It's actually not too difficult to do. We go to here. But the problem is there's no data. You're like, well, I just had data right here. Hopefully you remember by now. What do I have to do on the TI Inspire to get this to show up? I have to go up here and I have to name these. So we were talking about the bear's age. So I literally can just put in age. And this was its weight. Maybe if I can get in there. Weight. So please make sure you name it. And then once you've named it, I go here and it goes, hey, look, you've named some data here. I go down to the x-axis and I click and I call it the age. This would be a dot plot of the ages. In the past, we've gone here and we've done histograms. Okay. But what I'm going to do is I actually want to plot the X versus the Y. So I go over here and I click and I add the Y, which was weight. That is what this looks like. Is that what mine looks like? You're like, yeah, not so perfect, right? Look, 1, 2, 3. 1, 2, 3. I kind of see curve down here, kind of some spiking up. Curve down here, some spiking up. I'm looking for an overall pattern. Now be careful because on the test, yes, I will expect you to sketch it by hand. It should be pretty accurate. Just be careful, but that is something I expect you to do. It does ask whether there appears to be a correlation. You're like, I don't know, what does correlation mean? Correlation, literally, correlation. Okay? Basically, does there appear to be some relationship between the variables? When we talked about this, we thought, well, yeah, as the bear gets older, it will weigh more. That's not forever. It's not like if you have a 50-year-old bear, it just keeps gaining weight and weight. So there's going to be some point where this doesn't keep going. But at this point, we see some upward trend to a point. Then we have this really old bear that hasn't been fed very well, and so its weight dropped, right? So that's the other thing that you want to be careful is don't just draw some relationship here that doesn't continue. So I would argue, based on what I know, that I see an overall upward trend. Even though it's a little weak over here, we would call this an overall positive trend, but it's kind of spread out, so we would call that weak. So when we talk about correlation, there's two things that we look at. The direction. Is it either positive or negative? And the strength. Is it strong or weak? I argued that this was overall positive because most of the points are kind of going upward. We have kind of a positive slope. But look how the data kind of spreads out as we keep going, gets kind of worse as we go. That would make it a weak relationship. If the points were more clustered, we would call that strong. So what does this look like? Well, we can have kind of 4 different ones that we'll have. Let me see if I can add a page to this. All right. So we will have this one I argued was positive, but weak. And that is where the data is overall going upward. We have a positive slope that's kind of spread out. A positive strong correlation would be the same upward trend, but a lot more clustered. We can also have a negative weak, where the data is going overall downward, and weak means the data is kind of spread out, but overall it's going downward. Or you can have negative strong, which is where on the line the data is still going down, but it's a lot more clustered. The other option is that we can see no correlation. And that is where we just have kind of a bunch of points, and I couldn't see either a positive or a negative line making sense. I don't really see a pattern there. I don't see it going up at all or down at all. This we would call no correlation. Okay? So be careful, because there's one other thing I want to add to this, and this is really kind of a big focus of statistics. A lot of times people will misuse this. Correlation is a relationship between the two. So as the bear gets older, we are seeing that most of the bears are kind of increasing their weight. Does that mean that because the bear gets older, it will guaranteed increase in weight? We're like, no, it was a bad year. They didn't get to eat as much food, so maybe they grew taller, but they actually lost weight and they're really thin. So this right here, even though we see a correlation, some relationship, it does not mean that age causes your weight to increase. There are other factors. Plus, as you get older and older, a lot of people, they lose weight, right? So this doesn't make sense to draw this out in a long thing. We are looking for some relationship, but please be careful. Correlation is not causation. This is a fundamental idea of statistics. We do this all the time, right? People go, well, you know, if you ran tests, people that have more money tend to do better on tests. People that have less money do poorly on tests. Therefore, if you get money, you'll be smart. Utterly ridiculous. If I hand you a $20 bill, that doesn't make you smarter. If I have an issue where I'm, lose my job and I'm broke and having a hard time, I don't all of a sudden lose intelligence. You see some relationship between a performance on a test and income of a family, whatever, but that doesn't mean one causes the other. You have to be careful. Correlation is not causation. For years when I was growing up, I had people go, well, look, if you look at people, I feel like I've gone through this before, but if you look at people that have gone through and were born under electric wires, right? They tended to score lower on test scores. And so people were worried. They're like, oh my gosh, you live under electric wires. It causes you to not be able to perform as well, and your IQ goes down, and it's the little waves come down and affect your brain. No. Where do you tend to see electric wires in cities, right? When I drive around Bakersfield, when I drive around Porterville, I see electric wires, but then there are other areas I don't see electric wires. Older areas, they used to have electric wires up in the air, right? Newer areas, where did the electric wires go? Well, they buried them. Not because they're afraid of it affecting your IQ, though some people were freaking out about that back when I was growing up. But basically, because it's safer, because then people don't mess with the wires, it's safer for the electric company, so they started burying the wires. But older areas tend to have people that have less money, and so they have less money, they maybe have less opportunities, and so they don't learn, they don't perform as well on tests, but that does not mean you living under an electric wire affects your IQ. That doesn't mean that having less money affects your IQ, right? These are the things where we look for a correlation and we go, wow, the people that are in poverty are really struggling, what can we do? Well, why? We just give them money and all of a sudden they'll do better? No. They really need some opportunities, so we give them opportunities. But be careful. Correlation is not causation. Just because I see a relationship between two things does not mean one causes the other. Okay? So that should be it. That should be everything you need for the next chapter. So keep it up, and I will see you guys soon.